Hi students, this is Sivakumar. 12th standard business mathematics and statistics, chapter number 7, exercise 7.3. So far we have come across binomial distribution and Poisson distribution. In this exercise we are going to study about normal distribution. Okay. Now the definition for a normal distribution: a random variable x, capital X, is said to follow a normal distribution with the parameter mean, mu and variance sigma square. What are the two parameters? Mean and variance. That sigma represents standard deviation and its square is called variance. Its probability density function PDF is given by the formula f of x, that is equal to 1 divided by sigma into root of 2 pi e power minus half into x minus mu divided by sigma the whole square. X lies between minus infinity and plus infinity. That is a probability density function for normal distribution. Mu represents mean, sigma represents standard deviation, and its square, sigma square, represents variance. It is a bell-shaped curve, normal curve, that is a bell-shaped curve. It's the x-axis. That x-axis is called an asymptote to the curve. Asymptote means the curve never touches the x-axis. The tail of the curve never touches the x-axis. Therefore, it is called the asymptote of the curve. Sorry, this x-axis is called the asymptote of the curve. If it touches, no, that is called a tangent. It never touches, therefore, what's the special name? Asymptote. Okay. Now, it is symmetrical about the line x, that is equal to mu. The center line, that is called mean. Mu represents mean. Here, mean, median, mode and all equal. The center line represents mean, median as well as mode. It is symmetrical about the line mean. That means from minus infinity to this line, x equal to mu 50%, mu to infinity also 50%. So it's symmetrical about 50-50%. Now the next point is x-axis. Already I told you x-axis is an asymptote to the curve. What I am given here, the tail of the curve never touches the x-axis. The tail of the curve never touches the x-axis. That's why it's called asymptote. Now these are the properties to be remembered. Probability of x lies between mu minus sigma to mu plus sigma 0.6826. 0.6826 means 68.26%. Full percentage 100%. Mu minus sigma to mu plus sigma 68.26%. Like that, mu minus 2 sigma to mu plus 2 sigma 95.44%. And mu minus 3 sigma to mu plus 3 sigma 99.73%. 0.9973 means 99.73%. Now we can discuss about the standard normal distribution. Standard normal distribution, the random variable capital Z, that is equal to x minus mu divided by sigma, is said to be a standard normal distribution. Here, mean, that is equal to 0, and standard deviation sigma, that is equal to 1. Its PDF, probability density function, is given by the formula pi of Z, that is equal to 1 divided by root of 2 pi e power minus Z squared by 2. Z squared by 2, Z lies between minus infinity to plus infinity. Between minus infinity and plus infinity. The area under the standard normal curve is 1. From that 100% means 1. 100 by 100, that is equal to 1. So area under the standard normal curve, that is equal to 1. Here minus 1 to plus 1, that is equal to the same percentage. Minus here capital X, here capital Z. This is a random variable. This one is a normal, standard normal random variable. Okay. Here minus 1 to plus 1, area 68.26, minus 2 to plus 2, 95.44, minus 3 to plus 3, 99.73%. So maximum percentage when covered between minus 3 and plus 3, 99.73% out of 100%. Okay. It's an intro part only. Now problem number 5 in exercise 7.3. The first four problems, first four questions definition. Now fifth one. In a test on 2000 electric bulbs, it was found that bulbs of a particular make was normally distributed. Normal distribution given. Average life of 2040 hours. So average represents mu, mean. Mu that is equal to 2040 and standard deviation sigma that is equal to 60 hours. Estimate the number of bulbs likely to burn for more than 2150 hours, less than 1950 hours, more than 1920 hours, but less than 2100 hours. 3 subdivisions totally. Okay. Now problem number 5, given number of electric bulbs 2000, mean, mu, standard deviation, sigma. We know that Z, standard normal distribution, Z that is equal to x minus mu divided by sigma. So random variable capital X, mu that is mean, this one is a standard deviation, this is a standard normal variable. Right. Now first subdivision, look at the question. More than 2150 hours, it should be considered as x that is equal to 2150. So more than given 2150, when x that is equal to 2150, we have to find out the value of z that is equal to x value 2150 minus mu that is equal to 2040 divided by sigma that is equal to 60. Okay. Now 2150 minus 2040 that is equal to 110 divided by 60. 110 divided by 60, 1.8333. You just write 1.83, enough, approximately. I got the value of Z. Now you can draw that bell-shaped curve, normal curve. Draw the center line. Here minus infinity, here plus infinity. Center one, x that is equal to mu and z equal to 0. Here x value 2150, z value 1.83. Here z equals 0 here. Here z full of positive values, here z full of negative values. Here we have z equal to 1.83. 1.83 you can take anywhere in this region. I take over here. Z that is equal to 1.83. Draw one line. Should be perpendicular to this axis. Here x that is equal to, what is the x value? 2150. Now what is given in the textbook? You are given more than 2150. More than means greater than. Greater than means the right hand side portion of this line to be shaded. More than, what it means? Greater than. So right hand side portion of x that is equal to 2150 to be shaded. We have to find out this area. Therefore probability of x more than, that is greater than 2150, that is equal to probability of, we have changed the capital X into Z, greater than, the corresponding value here it is 1.83. 1.83. To find out the probability value, look at the diagram once again. Each and every time you must touch the point 0. To find the shaded region, first I take 0 to infinity, this entire area, including the unshaded portion. Minus unshaded portion, you will be getting this area. Look at that. Once again I tell you, probability of 0 to infinity full area minus this portion for getting this area, that is probability of 0 less than z less than infinity. What it means? 0 to infinity. You have to consider always left to right only, so that I have mentioned the symbol less than, minus probability of this unshaded portion to be shaded to get this portion. This is a required portion. So unshaded portion 0 to 1.83, 0 to 1.83. We have to mention only z value, 0 to 1.83. 0 less than z less than 1.83. The starting number should be 0 equals 0 to infinity. You know very well, that is 0.5. Already I told you, this is a 50%, this is 50%. 0 to infinity 50%, minus infinity to 0 also 50%. 50% means 0.5. 50 by 100, that is equal to 0.5. You can directly write. Here 1.83, you will be given the value in the question paper. Now you can refer the table, normal distribution table. 1.83. How to find? Here this normal distribution table. Here 1.8. Here 1.8. In 1.8, here 0.03 here. Here it is. This is the value 0.4664. 0.4664. 0.4664. Now you have to subtract 0.0336. 0.0336. Therefore, finally you have to write the result. A number of electric bulbs likely to burn more than 2150 hours equals, write the probability value first, 0.0336 into total number of bulbs what is given, 2000, that should be multiplied into 2000 equals, answer is 67.2. So number of bulbs, it cannot be negative, it cannot be a decimal one, so we can write 67 approximately, because after decimal point we have the number 2 only. If it is 5 or 6 or 7 or 8 or 9, we can write 68. So less than 5 have to write only 67, right? Now not approximately, you straight away write 67 only. Now subdivision number 2. Look at that, less than 1950 hours should be considered as capital X, 1950. When x that is equal to 1950, find the value of z. You know the formula, z equals x minus mu by sigma. Here it is, x value 1950 minus mu that is equal to 2040 and sigma that is equal to 60. 1950 minus 2040 equals minus 90 divided by 60, that is equal to minus 1.5. Now we can draw that normal distribution curve. Draw the center line. Here minus infinity, here plus infinity. Here x equals mu, z equals 0, minus 1.5, that's a negative value of z, so full of here negative values, so write minus 1.5 here, z equals minus 1.5, anywhere in this region, draw a line here, then x corresponding value, x that is equal to 1950, here it is. Now refer the question, what is given, less than means left hand side of this line to be shaded, this portion to be shaded. We have to calculate this area, shaded area. For finding this area, first time finding minus infinity to 0. Already told you, each and every time must touch that 0. Minus infinity to 0 means this portion, entire area. minus unshaded portion, that is minus 1.5 to 0. Don't say 0 to minus 1.5, minus 1.5 to 0. You have to take always left to right only. Therefore, probability of x less than 1950, we have changed x into z less than the corresponding value, that is minus 1.5. Already told you, probability of minus infinity less than z less than 0 minus probability of minus 1.5 less than z less than 0. Again I tell you, minus infinity to 0 minus 1.5 to 0. This portion to be subtracted for getting this area. Then already told you, the first number to be 0, so that you can interchange. If you interchange, you have to change the sign. Symbol and all same only. 0 becomes minus 0. No chance of writing minus 0. You write 0 only. But minus infinity become plus infinity. So probability of like that. Here 0 only, less than z, less than minus 1.5 become plus 1.5. Because minus infinity to 0 and 0 to infinity same area only. It is symmetrical about the line x equal to mu. See? Minus infinity to 0, 0 to infinity, area wise same. Like that, minus 1.5 to 0 and 0 to 1.5, area will be same only. So now 0 to infinity, that is a constant value. Already told you that is a 50%, that is 0.5 minus. Now you have to calculate the area for 1.5. You have to refer the table, normal distribution table. 1.5 here it is, just 1.5 only, therefore 1.5 0. In 1.50, that is 4332, 0.4332, 0.4332. You have to subtract 0.0668. Okay, now therefore number of electric bulbs likely to burn, number of electric bulbs likely to burn less than 1950 hours equal 0.0668. that is a probability value into total number of bulbs given, that is equal to 2000. Have to multiply 133.6. that can be written as, can be rounded up to 134. But look at that, first number is after decimal point, what's the digit? 6. If it is 5 or more than 5, the 1 can be added with the integral part. 133 plus 1, that is equal to 134. So number of electric bulbs likely to burn less than 1950 hours, that is equal to 134. 2 subdivisions over. Now third subdivision, more than 1920 less than 2100. That means between these two, 1920 2100. First I consider 1920. When x equal to 1920, z equals formula x minus mu value, that is given 2040 divided by sigma, that is also given 60, equals, you have to subtract 1920 minus 2040 equal minus 120 divided by 6, that is equal to minus 2. Now next value of x is 2100. When x that is equal to 2100, when x that is equal to 2100, find the value of z. Z equal to x minus mu, that is given 2040 divided by sigma, that is equal to 60. 2100 minus 2040, that is equal to 60 divided by 60, that is equal to 1. Okay, now you can draw that normal curve. Center line, x that is equal to mu, z equal to 0, minus infinity, plus infinity. Here we have minus 2 one negative number, one positive number. Minus 2 I take over here, z equals minus 2. I take 1 here, z that is equal to 1. Positive, here negative. Corresponding x values you have tried. Here x value 1920. Here x value 2100. Draw a line. Here x value 1920, x value 2100. We have to calculate this area between these two lines. Okay, now probability of x lies between 1920 and 2100. We have changed the probability x into z, the corresponding value is minus 2 and plus 1, minus 2 and plus 1. Each and every time you must touch that point 0, already told you. So minus 2 to 0 plus 0 to 1, both the area to be added. So probability of minus 2 less than z less than 0 plus probability of 0 less than z less than 1. The first number to be 0 here, okay, but look at that, we have to interchange. That means probability of 0 less than z less than plus 2. You better to write for your reference by symmetry. Minus 2 to 0 and 0 to 2 or area wise same only. Even here also I write by symmetry. Here also by symmetry. Here the starting number is 0 only, so write this one as it is. 0 less than z less than 1. Now we have to refer the normal distribution table for getting the value for 2 and 1. 2, that means 2.0, 0.4772. 0.4772 plus for 1, that is 1.0. Here it is 1.0. 0.3413. 0.3413. Both to be added. We add 3 plus 2 5, 1 plus 7 8, 11 8, 0.8185. Now therefore number of electric bulbs likely to burn more than 1920 hours and less than 2100 hours equals. First you have to write the probability value, that is 0.8185. that should be multiplied with the total number of bulbs, that is equal to 2000. If you multiply, you will be getting 1637. So 1337 bulbs. So problem number 5 is completed. Then I will be teaching problem number 6 in the next video. Thank you, children.